All right, hello, Aiden. This is the second half of 3-2 notes. We did the first half yesterday. And here we go. Before we do example 3, let's do this real quick. Off to the side over here, do you see where example 3 is on your page?
Yeah.
Off to the side, there is like these dotted lines, right? Or like whatever dotted lines, notebook paper. There you go, lines. We're going to write out what's called a truth table. Okay, and this is going to maybe clear up some stuff about the and or thing. Okay, here is my truth table. I'm going to make a table that's going to have 4 rows and 4 columns. 1, 2. My second 2 columns are going to be a little bit bigger. Maybe. Okay, 4 rows, 4 columns, just like that. And some room for headings. This is my truth table. Four rows, 4 columns. Here we go. All right. When we do like statements, we usually give variables to their names. So like statement P and statement Q, right? Or R or T or whatever, right? Just so that we can name them short. Like statement P is, who should I pick up? Megan. Megan is, are you a sophomore? Megan is a sophomore, right? Statement Q, Megan is a girl. Right? We'll go with that. Okay. So P, Q. Then let's talk about what P and Q would look like and P or Q would look like. Okay. Got it? So the and is an A and the or is a V. If you need to write that down. And or. And this is kind of like your cheat sheet. Ooh, or. Your little cheat sheet. Okay. So we could have P be true and Q be true. So that would be like Megan, if we're talking about Megan, this would be that she is a sophomore and a girl, right? Sophomore, girl, true and true, okay? So is it true, let's fill in P and Q. Let's say that the first one is true and the second one is false, right? We'll write out what that looks like here in a second, okay? What's another combination of P and Q that I can have? False, true, and false, false. Okay, so if we look at this in terms of an and an or, okay? If we say that statement P is that Megan is a sophomore and statement Q, Megan is a girl, is it true that Megan is a sophomore and Megan is a girl? Yes, so true goes in this spot. Does that make sense? Okay, is this one and this one true? Yes, so the whole thing's true, okay? Now, is it true that Megan is a sophomore or Megan is a girl? Yes, double bonus because she's both, right? So this one is true or this one is true, so the whole thing is true, okay? Now let's go sophomore and boy. Megan is a sophomore, true. Megan is a boy, false, right? So is it true that Megan is a sophomore and Megan is a boy? False. Is it true that Megan is a sophomore or Megan is a boy? Yes, that's true. You see how this works? Okay. Now this would be like, let's say freshman. Megan is a freshman. And then statement Q would be Megan is a girl. Freshman and girl. So, is it true that Megan is a freshman and Megan is a girl? False. Is it true that Megan is a freshman or Megan is a girl? True. Okay, and then let's go freshman and boy. Which both are false, right? Megan is not a freshman, Megan is not a boy. So, is it true that Megan is a freshman and a boy? False. Is Megan a freshman or a boy? False. Okay, so this is how this works. In order for an and statement to be true, both pieces have to be true. Otherwise, the rest of the time it's false. If any part is false, the whole thing's false. Okay? But for an or statement, only one or the other has to be true. So the only time that that's false is if both parts are false. Make sense? So ands versus ors. It's 3 and 1 and 3 and 1. Got it? Make sense? Kinda-ish?
Sure.
Okay? All right, so that's how that works. Okay. All right, let's go to example 3. Here we go. Hypothesis, conclusion. Hypothesis was the if part, conclusion was the then part, okay? And sometimes they word the then part first, okay? So identify the hypothesis, conclusion on your homework assignment. If you just want to underline, I am totally fine with that. If a polygon has 6 sides, then it is a hexagon. If a polygon has 6 sides is the hypothesis, conclusion, then it is a hexagon. HC, if you want to just label them like that, if you have to do that on your homework assignment, perfect. Okay, B says another performance will be scheduled if the first one is sold out. What's the hypothesis?
First one is
If the first one sold out, that's a hypothesis. So this is an example of when the if part comes second. Another performance will be scheduled. That's the conclusion. Got it? I won't make you write it out. Okay? You will have to write out a bunch of other stuff in this section. So that's kind of the icky part. Okay? Good? Happy with that? All right, let's move on to the next piece. Now, they want you to write it in if-then form. So they give me a statement. 4 quarters can be exchanged for a $1 bill. So here is how they interpret that. They say, if you have 4 quarters, that's my hypothesis, then you can exchange them for a $1 bill. That's my conclusion. So notice that they had to add some words in there and change it around a little bit. 4 quarters can be exchanged for a $1 bill. If you have 4 quarters, then you can have a $1 bill. Make sense? They have to insert some words in there, okay? All right, so let's do this one. The sum of the measures of 2 supplementary angles is 180, okay? Let's write the if-then form. Let's skip to this part. Let's write the if-then form first. How are you going to put that in if-then form? If what?
If the angles are equal to 180, then it is supplementary.
Sure, that's a way of doing it. So if the sum of 2 angles is 180 degrees, then the angles are supplementary. Could you do that another way?
Yes.
Could we do if supplementary, then they add up to be 180? Sure, we could do it that way too. All right, so if that's the case, hypothesis is the if part, conclusion is the then part, okay? So conclusion would be supplementary, hypothesis would be 180. Happy with that? That's not too bad. So sometimes you have to add and be a little bit creative when you're doing this, okay? Adding in some extra words. All right, let's go to example 5. Okay, we've got some fish stories going on here. There's a long paragraph, so I'm going to read this kind of fast. Okay, are you ready? We're talking about a tang fish. Have you ever heard of a tang fish? Any fishermen in here? I have no idea what a tang is. Not a clue. Tang? The tang is a saltwater fish that inhabits shallow coral reefs in tropical areas. Tangs are a part of the I can't say that. A part of a particular family. What? Yeah. Okay, that sounds familiar. Like a blue tang fish? Yeah, I know what you're talking about. Is Dory a blue tang fish?
I think she is.
Yeah. All right, so they're a part of a particular family along with surgeon fish and unicorn fish. All members of that family are saltwater fish. Write the converse, inverse, contrapositive of this conditional statement. All right, so here's our original. Circle this. Tangs are fish that live in saltwater. Tangs are fish that live in saltwater. That's what we're starting with, okay? And so we have 4 parts. We have the conditional statement, which says P, Q. It goes P, then Q, okay? And then we change it around to make the converse. The converse is the opposite. So it goes Q, then P. So we flip the statement around. All right, so let's do those 2 first. Tangs are fish that live in salt water. So they have said if the fish is a tang, then it lives in salt water. That's how they've interpreted that. Okay, and we usually assume that the conditional statement is true. So if it's a tang fish, it lives in salt water. We can gather that from the paragraph above. That is true. So if we're doing the converse and we're flipping those around, we're doing this little whoop-de-doo thing. If the fish lives in salt water, then what? It is a tang. Now, we have to decide if that's true or false.
It's false.
Right? So the statement says, if it lives in salt water, then it is a tang. True or false? False. So counter example, a surgeon fish, which it says up in the paragraph, also lives in salt water, but it's not a tang. So therefore the converse is false in that case. Does that make sense? Okay, so we have to go through, flip all the statements around. We have to see what is what, okay? All right, so now I'm going to go down to inverse is the next one. And I always draw an arrow from conditional to inverse because conditional is PQ. And this one is also PQ. But you put not in front of each side, right? So not P, not Q. Instead of PQ like the conditional, not P, not Q. Okay? So this one said if a fish is a tang. We change it to if a fish is not a tang. Then it lives in salt water means then it does not live in salt water. Okay? All right, so we have to decide if that's true or not. If the fish that I'm talking about is not a tang fish, Does that mean my fish can't live in salt water? My fish is not a tang fish, so therefore it doesn't live in salt water. True or false?
False.
False. I could have a surgeon fish, right? I could have a surgeon fish right here. And that surgeon fish still lives in salt water, so that is false. But
it can be any fish.
What?
It's just a surgeon.
Well, they just say give me a counterexample. So yes, you're right. It could be any fish, but we only have to give one. That makes sense? Okay. So a surgeon fish is not a tang, but it can live in salt water. Therefore, the inverse is false. All right. Last one is the contrapositive. So I draw the contrapositive like linked with the converse. Converse went QP. What's contrapositive do? Not Q, not P. Right? We do every combination. So converse and contrapositive, not. Okay? So the converse was if a fish lives in salt water. This one says if a fish does not live in salt water. Okay? Then it is not a tang. So the fish that I have in my hands right here is a fish that does not live in salt water. So am I saying this fish is not a tang?
Yeah.
True. Right? The fish that I have is not a saltwater fish. Therefore, it can't be a tang because a tang is a saltwater fish. Okay? So, true. All right? Got it? That was a lot. This is going to be just like number 19 on your homework assignment. You've got to write out the, and they give you the conditional equation on number 19. They might not write it in if then form. You don't have a whole lot of room, but I only gave you one of them from down in that section, so if you need to write it like off to the side, down below, underneath, whatever, okay? So you have to write all of those. Ugh. That's a lot, okay? All right, let's do the last thing. This is something called a biconditional. A biconditional. So I'm going to go up here to the top. And on the top, I'm going to put the conditional. And let's say if it rains, then the parade is canceled.
Wait, where are we?
I'm writing this at the top of biconditionals. Biconditionals. The conditional equation is that if it rains, then the parade is canceled. This is an example that we had yesterday. Okay? If I do the converse of that, converse means just flipping it around. What would the converse look like? If the parade is canceled, yeah, you're right. If the parade is canceled, then it has rained. Or I'm just going to say rained.
But I thought.
Okay? Now, we have to decide whether it's true or false. Okay? So the top statement, if it rains, then the parade is canceled. They said that that was true. In the bottom, if the parade is canceled, then it has rained. That is false. Okay? So what we're doing is when we're doing a biconditional statement, we have to look at both the front way and then the converse of it. And we want to determine whether that whole thing is true or false, right? Okay? So let's say that the second one was true. If we assume the second one was true and there's no other reason for why the parade would be canceled, then we could write this as if the parade canceled. No, don't write that down. I want to go, the parade canceled. It canceled if and only if it rains. Okay? So if this statement is true and this statement is true, I can write it as one thing and I can put if and only if in the middle. Does that make sense? The parade will be canceled if and only if. That means only if it rains is the parade canceled. Right? The parade will be canceled if it rains. If it rains, the parade is canceled. It works both directions, right? So if both statements are true, I can write it as what's called a biconditional, where you have if and only if in the middle. Got it? All right, let's do one of these. So they use the example here that says if he earns a 3.5 GPA or higher this semester, that's like statement P, then he will be accepted into college. That is Q. If Aaron is accepted into culinary school, that's Q. Then he has earned a 3.5 GPA or higher. So they've done the conditional and they've done the converse, right? They've done it forward and backward, okay? And they're saying both of those things are true. If he gets a 3.5, he'll be accepted into school. If he's accepted into school, he got a 3.5, okay? So they bump down here to the biconditional that says Aaron will be accepted into culinary school if and only if he got a 3.5 or higher. Only under the circumstances that he gets a 3.5 or higher does he get accepted. If and only if. Have you guys heard the word if and only if before? Maybe? Yeah? Okay. All right, so let's write a biconditional. So here is our conditional equation. They want us to write it in if-then form. And then write the converse and then write the biconditional. We got lots of steps. Okay? So it says Rasha listens to music when she is in study hall. Rasha listens to music when she's in study hall. So if she's in study hall, then listen to music. I'm really paraphrasing. If she's in study hall, then she's listening to music. Is the conditional statement true or false? True, because they're saying that that's how that works, okay? If false, provide a counterexample. We get to skip that. All right, the next one, the converse. Flip it around. If what?
If she's listening to music,
If music, then she's in study hall. If she's listening to music, then she's in study hall. Is that true or false? False. Why?
she can listen to music.
Yeah, so let's say she could be at home listening to music in her room. She could be home, or she could be in another class, right? That's my counter example. Provide a counter example. She could be at home, okay? So because the converse is false, if one of them's false, we cannot write a biconditional statement. I can't do the if and only if thing. I can only do it if both of them are true. Got it? That's what we're going to see in this next one. Okay, so if two lines are parallel, we've got two lines that are parallel right here. I'm drawing a picture. If two lines are parallel, then they have the same slope and different y-intercept. Okay, do you know what slope is? Up and over, up and over. Do they have the same slope if they're parallel? Yes. Do they have different y-intercepts? Let's say if I put this on a like xy axis. This is intercepting here, this is intercepting here. Do they have a different y-intercept? Yes. So the conditional, if parallel, then same slope, different y-intercept. I'm really paraphrasing. If they're parallel, then they have the same slope and a different y-intercept. True or false? True. Okay? Now let's flip it around. If what? If same slope, let's go. Same slope, different y-intercept, then parallel. Okay, is that true?
It's true.
That is true. If they have the same slope and different y-intercept, they're going to be parallel. Okay? The conditional and the converse are true. So a biconditional, what goes in this blank? Can be written. Okay, let's write that biconditional. Two lines are parallel. If and only if, same slope, different y-intercept. Okay, so that's what they're having you do is they're taking these two and they're putting it into one by putting if and only if in the middle. So you don't have to write it forward and backwards. You only have to write it one way, but if and only if goes in the middle. Got it? Lots of writing. I'm sorry. It gets very tedious. Okay, one more example. You ready? Okay, they say this is the biconditional right here. Two angles are complementary complements if and only if their measures have a sum of 180. So they want us to write the conditional and the converse. Now they want us to separate it apart and see if it's true or false. Okay? So, write the biconditional statement as a conditional and the converse. Two angles are complements if and only if their measures have a sum of 90. So if what? If I separate him into pieces, if something, then something.
If two angles measure up to 90, they are.
I'm going to go the other way. I'm going to go if complement, then sum equals 90, just because that's the way that it appears in the statement, right? If they're complementary, I can't spell, there's an R in there. If they're complementary, then their sum is 90. True or false? Complementary angles, do they add up to be 90? Yes, true. Okay. All right, now let's do the other way. If what? If sum equals 90, then Complementary.
Because that's
Is that true or false?
false.
If they add up to be 90 degrees, do they have to be complementary?
No.
Yeah, they do.
What if
Yeah.
they're just
Separate.
two angles
Or is
separate?
that all?
They don't have to be touching to be complementary.
Since when's that a rule?
Didn't
That's
we
always been a
say
rule.
That's
I
just,
thought the other day.
that's just like saying that if
Well,
they
The
have
other
to
day that there was a question
be
where.
on
Nope.
a linear pair.
So there was another, yep, relating back to Megan's thing. So the other day we had a question that said, talked about linear pairs and supplementary, right? Linear pairs are always supplementary. Does every supplementary angle a linear pair always? I could have one over here and one over here. We did a counter example for that, right? They don't have to be touching to be supplementary, to add up to be 180, but they don't have to be touching, okay? But every linear pair is supplementary, but not every supplementary is a linear pair. It's like the converse, right? The converse is not always true, okay? But in this case it is. If the sum is 90, then they're complementary, so it's true and true. So the conditional and the converse are true, so the biconditional, the original one that said if and only if, that is true as well. Does that make sense? We read it forward, we read it backwards. Both ways it's true, so the whole if and only if is true as well. Okay, got it? Okay, so to the homework assignment that you guys started yesterday, I am adding 24 and 26, and that's it. Can you do that?
I suppose.
I suppose. So 2 through 16, even 19, 24, and 26. Okay, if you get stuck or don't know how to word something,
I forgot
you
how to
just
do
holler.
246.
what?
246, like I forgot how to do that because.
I'll come help you. Okay? All right? Any questions before I shut video off? Okay, Delaney, I'll come help you.
Okay.
Escape.